part, we will focus a bit more about challenges in the information age, and I think we touched some of the topics that we're going to talk about right now already in the first part. And we have the following setup that Michael from Herzog de Meuron, he will start. He will talk a bit about their journey, how they moved away from just using software to also shaping and developing their own software, and what challenges comes with this in the realm of data, obviously. And also about the relationships with services they use more and more. And services they use more and more is the second part of the introduction is from Fanus from 2050 Materials and Hans-Uli Schmid from Lignum, who talk about what it means for them to gather data and to provide it through an API. And last but not least, I'm really happy to have Philip Dohmen here as well. And he will talk about the relevance for structured data and what it means for organization to work data-centric. Very curious to see and hear what you're going to present. But I'll hand over now to Michael.
Thanks a lot. Can you hear me? Awesome. Oh, okay. Awesome. Thanks a lot. Welcome, everyone. So I changed a little bit the title to make it simpler from software to data. Let me introduce quickly. So I'm Michael. I'm since 2014 at HDM, hired by Kai, just a side note. And I have a, let's say, background in BIM management, computational design, and now I'm running the design technologies group, which is as well partially around here. Let's come directly to basically our challenge. I mean, you know, more or less, hopefully, what we produce, basically architecture worldwide in different scales and typologies, and basically what are the challenges we're facing or we can foresee basically for some topics. There are definitely regulations is one topic, something like taxonomies or sustainability regulations, at large sustainability, the topic of digitalization, and obviously the people, like we heard it before, upskilling people is a big topic. So to understand at our portfolio how to operate in sustainability, for instance, or in how to improve digitalization, we need to understand better the projects. We need a better understanding of the data, of the models, and basically we can't waste time. We need to do it automated. So basically, this is something that is a challenge, and the data in itself got a challenge because how we operate our company. So it's not following the business cases. We have to find ways how the data aligns then with how we operate. So we are an international operating company, meaning in all the different scenarios, we have different delivery models, contractual models. This you can overlay that with something that is more obvious, basically, that with all the typologies and scale we have small projects, housing, until stadia, and something like special projects like hospitals or other typologies. And obviously, we have a design complexity. So we're interested into having a kind of a nice design and something that's kind of is represented and can be quite complex. Meaning, when we deliver data, we deliver to all the standards that are possible. So this is kind of a challenge to the data, and to create that data, basically, we come as well, unfortunately, we have a huge package in the backlog of tools. I mean, we are mastering those, but something that needs to be as well thought about, meaning each and every delivery with different data sets comes maybe with comes from a different source. So this is kind of everything overlaid, creates a challenge. When you look at sustainability in particular, as well, different regulations, different calculation conventions, all that together is a little bit a difficulty. However, we love to make it even more difficult. So basically, when you think about the design process, it's in theory, it's in phases, but you can more or less forget that. The reality is you do a lot of options, discussions, talk with clients, go back and forth, redecide. That's more or less the option. So where is the state where you can, let's say this is complete in terms of data, in terms of let's say 100% fulfilled, that I can basically take off something to do a simulation or whatever. And in the end, it's getting more and more and more. So this is something basically to, let's say, formulate the big problem statement. So when we come to the goal is, we want to compare stuff. That's how we operate in the company already. We do a lot of references from other companies, from our own company. We're trying to understand what is an appropriate solution to as well work with knowledge, basically. And knowledge means as well to understand, okay, this concept, how is that transferable in another context? So basically you need to compare things. So this again is something that is a big challenge. I mean, data, meaning like area data over the globe, is calculated differently. How do you compare it? Carbon footprint, how do you compare it? And so on. So, and how do you do that on a portfolio view, basically, on organizational view? So I'll guide you quickly to two topics, basically. One is the data strategy. So meaning we're leaving now the classic out-of-the-box software. We use it, deliver, done. We expand here. And the other one is a real use case, basically, that we developed that as well has some software development inside. So we need to understand the design process. So we want to make the data transparent. How is it calculated? All these things. We want to make it comparable, and we want to be flexible, basically, for future use. So when you look at the design process and the data that's accumulated, normally you have a start, you have an end, and that's how offices operate. Basically, they archive the things. It's a silo. A project is a silo. We heard it before as well. It's all prototypes. It's a general problem of the industry. We create prototypes and they're in folders and they're stuck. Meaning, can we access that information that is the real, let's say, gold in that sense, that is the process and the data that we can as well backtrace and say, okay, that is the data of that state, so we know the complete picture. So we try to think about how can we do this. Already here you can see the solutions, basically. So we had to introduce, let's say, repositories for that. So one is for geometry speckle, and the other one for, let's say, more broader data and calculation data. And the process data basically is a headless system directors, basically. And so this is the technology, but how is the process in the data pipeline? So in a way, there are three streams, basically, we identified. One is the design team. Basically, they create and they consume. That's it. So they don't want to, let's say, be part of any data creation transformation process. Already IFC exports are quite overwhelming for teams. So how do we bring information out of this basically loop into teams and basically give them information? So it's something that we as design technologies basically operate in this middle layer. So we have to extract all the information, transform it, and load it into something we call snapshots. So basically the data layer that's basically then we can filter and work on it, bring it to dashboards, and then bring it to something that is then consumable by the architect again, that basically they can compare. And the vision is to be able to operate it over the lifetime of a project, basically with different snapshots, and that we store data that's all transformed, unitized, harmonized, that we can create comparable data over projects. So that's the basic data strategy, basically. And when you look at one use case, it's embodied carbon. Obviously, we're facing here an industry challenge, and currently what we see is a lot of software, a lot of approaches, consultancies, but it's something that always comes after a stage. So you calculate something after the design process is done, more or less, for at least for a certain time. So you lose time, basically. So you are not, let's say, ingesting the right information in the process, basically, early on. So we have to figure out how to do that. So we call this calc. Some let's say images of carbon footprint and calculations are inside. And basically, calculating carbon is quite simple, supposedly. So it's a material, quantities, you have material performance data, the warming potentials basically, and then you can calculate the totals. Simple. However, the problem comes more that you need to calculate it through. Basically, you need all the data and information. So we're trying to figure out, okay, what are the stages in those calculations, and think about what should we do. So basically, the approach here is to go into this highly let's say modeled element and highly calculated element and apply them to early stages. As interestingly, the bridge to this volumetric wood models versus basically the high-end detailed models maybe you can find here. So the idea is to really go into element level to calculate it and then bundle up elements into assemblies, into systems. And then these systems basically as well not only calculate the carbon footprint, but as well assemble all the information that is relevant to make an architectural decision. With that, basically, we are able to make a decision early on without calculating everything, but we need real calculated data for that. And with that, we can apply that again to simpler models that are maybe just surfaces, even in Rhinos. Currently, it's only operating on our side in Revit. But this is something as an idea that you can have like simple geometry and see what are the main drivers of carbon footprint. But again, it's kind of this closing the loop of thinking about, okay, what is potentially in the project? It's too much to define, but we take it off the shelf with all the relevant information and ingest that information that comes from real projects, again, in future projects to be able to calculate and break it down basically in the way we need it. So what we did was we created two tools basically. One is to create these assemblies, to create a library basically. So because there is no library for us, so we needed an engine to generate. And the other one is the engine to calculate based on the assembly material library basically we have. And how does it look like? So the calc builder in the center as a tool basically takes Revit components and basically combines them, the calculations with the material data that is basically in the background 2050 materials API we use to store data, and then we can basically process that into this app layer basically in the middle. Then we create these assemblies. In the end, not the PDF, sorry for that, a dashboard. So in that sense, we kind of bring that again to someone that can consume it and get that information out. And same is for basically the project level where we calculate project, let's say carbon footprint data, is we take again the assemblies, we hide more or less the material performance data because this is something no one in the architecture work can operate to assign that, at least not efficiently. So basically it is something that's above efficiency. And then you have the pre-calculated elements and can bring them into the calculation basically. And then in the end, store and distribute into a consumable format again. How does it look like for everyone who's a little bit technically interested? I mean, in the end, it's something that brings everything together. I mean, this is, you see some readable format, more or less. We discussed with Christian about LCAX, EPDX as well. Had a lot of exchanges with industry partners, basically about this, and figure out to have a simplified scheme, but however we could basically enlarge that to maybe something that is hopefully at some point an industry standard. Same applies for saving the geometrical data. Basically, we went here for speckle, that we are able to bundle everything in a consumable way. So in the end, this is something that we have internally as a dashboard that that basically brings all together, that you can have 3D information, 2D information, still valid, and basically comparable environmental impact with the whole things like loads, acoustic rating, fire rating, whatever you need, that you are able in an early design stage to make your decision basically and have the biggest impact, and not wait 4 weeks until someone calculated your model that is incomplete and comes back to you, sorry, I'm missing that attribute, can you bring it to me? This won't happen. So this is exactly the challenge we're kind of trying to address. So this is, let's say, this solves one problem. The other one is, let's say, this maybe an internal problem, maybe just something that is, let's say, only to our, let's say, profession. When it comes to this one, is a little bit more interesting because so we had as well to figure out, when we think about the breakdown of a project, we need a scheme. And the scheme is not a BIM scheme, it's not an IFC scheme, it's a project scheme, it's a building scheme, basically, that allows us to store that data, basically. And so what we do is basically we really go through and transform all the models in that sense, that we query them, we group them into buckets. Again, we have some rules, bring them again there. And then in the later stage, we can map the environmental data to assemblies. So meaning, this is a transformation of the model, and this is something that we as well store when we store the models. So let's go to this one. So when we have a project snapshot that basically has the state of the model, we as well store the transformation of the model, the queries we did, and the assigned, let's say, materials and stuff like that. So it knows which material from 2050 came in and stuff like that. So it's a backtraceable system, basically, that we understand. It's not a PDF. I think that's what we're trying to get rid of, PDFs, because PDFs, you get a PDF, look at that, someone did this. You don't know what it means. It's really useless. And we are facing the big problem of always hunting information that is somewhere behind the PDF, and this person most likely is gone from the office, then you won't get the information. So a little bit how it looks like. Obviously, it's web-based. You have to log in. You get kind of a nice user interface. I mean, this is also something you have to work on the user interface, that architects as well in the future will like to work on it. And basically, I mean, you can see it. It's still kind of this middle layer which a specialist needs to operate, although it's something that is let's say, quite optimized for us. However, in the end, the let's say visualization layer is the dashboards, and that's what the project will consume. So what do we want to do? Get rid of PDFs, have it centralized, standardized, or let's say have this approach that you can transform, have it very flexible and transparent. And the vision is that this is something you can have on the organizational level, really, to calculate it through, to have then the dashboard basically to be able. So it means how to store the data of your work in that sense. What is the repository? Where is it? Is it something open source? Is it something that you can read in the future? Is it something you can, let's say, migrate to other systems? So this is exactly a big challenge, basically, we can foresee for the future. And as a next step into the digitalization, basically, we're facing. And this is something you need to talk to people. So basically, open source, open ideas. So we had a lot of collaboration with Hen, with some engineering companies, with, let's say, people who create, let's say, platforms that are basically competing in that sense, or other, let's say, competitors, architects, basically. And it's a really important thing, basically, that you discuss that and trying to find, let's say, a common ground to address basically the big problems we're facing currently. And so we decided as well to put that open source, and Max put it as well nicely in the incubation chapter of open source construction. It is something maybe that is difficult to collaborate on. We saw that with Speckle LCA from Link.io from Denmark, where we thought we could collaborate. We did the same approach with Hen from Munich, where we thought we could collaborate and share codes. We failed on this one. But however, in this kind of open ideas and exchange layer as well helps a lot, basically, to make shortcuts and be more efficient in that sense. And thank you all for listening. Thanks.
Thanks, Michael. And I'm really excited to see how this will develop further, because I mean, you open source it now, and it's still not easy for others to access it and to work with it. Yeah. But some things or like everybody does it, like the assembly library, for example. So, and finding or like collaborating on individual parts that everyone can then again process in his own tools could be one step further, for example. And
I mean, it's open sourcing ideas as well to have, let's say, approaches that are basically relevant and to share that and have exchanges and feedback as well. I mean, this is something as well
crucial,
important. So.
Because you define structure, and once you define it and build software on top, it's not easy to change it again. So to discuss it and get feedback from others helps a lot to make things future-proof. So we will discuss more details on the podium in a second. Panos, see you from there. Yes, I don't have it on. You want to have, you hold the mic like this, or do you want to do?
Either try to hold the microphone.
Super. Pretty dark.
Yeah.
Oh yeah.
Do you have?
I guess it's this one.
Yeah. I had it open, but it seems like.
You need the code for the Wi-Fi. 1 second.
I know, actually. Well, if you have it, it's better. Otherwise, I found already.
Okay, no. Ah, yeah, wait. Did you have it? Because you have to enter it here. Sorry. I have like so many slides. So it's this 10.
No, actually, okay. That's fine.
Can you press it?
But I don't see where.
Because you mirrored the screens. You didn't mirror it, but you. Let's do it.
Okay. Sorry for the technical difficulties. Yeah, hi everyone. I'm Fanos. I'm one of the co-founders of 2050 Materials. Thanks again, Max, for the invitation, and thanks to everyone for being here. I was here last year for the first time, and it's a super cool event, I thought. And I'm super happy that Michael started with the presentation because it makes my presentation way easier. So what I want to talk about today is basically about embodied carbon data and sustainability data, but really focusing on what data is fit for purpose for each stakeholder in the construction process. And I think Michael already touched on this topic quite a lot, but architects and engineers and developers and clients, they don't all need the same kind of data. And actually giving them all of the data kind of creates a barrier to progress. So maybe to state the obvious here, there is the climate transition that's happening in the industry, and it creates a big amount or a big need for data. So a simple example in some of the more developed markets is that we see carbon budgets being proposed on projects, which means they need to be met because that's something that either the client or the regulator is asking for. But to do that, if you're not Herzog's team, you need to essentially gather data and crunch them, usually in an Excel file or in some sort of software that's still very, very manual. And to put it in kind of monetary terms, it really costs a lot for projects. And what actually happens is that there is a consultant that does a lot of LCAs, for example, for the project, and then ends up giving a report that we cannot really act on, and we've already spent all of our budget. So even if we want to act on it, like we just don't have enough budget to go back. And what we're building at 2050 Materials is we are essentially gathering a lot of that data and then offering it, if you like, to the industry so that the industry can build different kinds of tools and processes so that it makes it much easier and much cheaper, ideally, to comply with the climate transition. And as I said, I'm super glad that Michael presented the tool that they've been building, because that's one of the examples of what you can use our data sets for. But it's super interesting to actually see from our position what other use cases there are. So there's everything and anything. So there's Revit plugins, and there's dashboards in Power BI, and there is companies that are building emissions tracking based on invoices that arrive on the construction site. There's all kinds of cool stuff. And the really interesting thing is that you can build all of these things with access to the right data, because you don't spend your time gathering the data, but rather you spend your time plugging the data into whatever cool idea you come up with. Now, when we talk about data, there's probably more types than the ones that I'm showing here, but I think these are sort of what I think are the most relevant ones to note. So there's 3 categories, the way that we see it. The first category is product and material data. So the ones that work in Switzerland and think of KBOB, for example, that's material data, so kind of generic information on materials. Product is a similar thing, but it's connected to manufacturers. So it's, for example, anything that comes through an environmental product declaration. And then all of this data can be aggregated into assemblies and systems. So again, like Michael presented in their tool, where they're getting KBOB data and they're aggregating it and grouping it so that they have slabs and facade systems and whatever else architects can actually work with. And then there's a further layer of abstraction, which is what I would call benchmark data, which you can think of it like, for example, embodied carbon emissions per meter squared of area of a typology. So it's something that the client can look at, or even a regulator, to start understanding what benchmarks should we be setting, what is high, what is low. Now, I don't know if this qualifies as big data, but I think it's getting there slowly. So there is around 200,000 EPDs. There is 10,000 generic materials systems and growing. There's a bunch of architectural systems that are public, and probably millions more that are not public within architectural firms. And then there is a bunch of white papers that hold a lot of data. So all of this data is very, very useful and very crucial in the transition. But my argument for this presentation is that we don't all need all of the data. So it's great that the data exists. It's great that there's a place to go get it, but we shouldn't dump all of the data on everyone in the process, because what ends up happening, at least according to my experience and what I've seen in the industry, is that an overwhelmed stakeholder is just like a stakeholder that doesn't have time to do the thing, and eventually does not do the carbon calculation, or does not build the dashboard or the tool that will actually lead to progress. Maybe briefly to walk through a little bit of an idea of how the climate topic happens within the industry. And this is a super simplified approach, but I think it helps to make the point of what data we should be using. The first step is scientists do research, like IPCC research or UN research, and they define what are the global emission budgets that we should stay below as humanity in order to avoid catastrophe. Then part of those emissions comes from buildings. So then real estate investors say, okay, out of the 42 gigatons of emissions that we should be emitting next year, 10% applies to buildings. So let's define how we will reduce our emissions on each portfolio that we have. Then developers take those budgets and they essentially break them down even further to specific typologies that they have. So they might say, from this reduction that we're doing on our buildings, let's apply 10% reduction to our residential buildings and 20% to our commercials. And then architects basically get a budget, if you like, for a building, and then they start needing to do the calculations of the optimization to achieve those. And then finally, the contractors who actually do the building and the procurement and all of that need to procure the right kind of materials and products and build according to what was set up initially. Now, simplified process, as I said, and probably not applicable to everyone in the industry, but what I want to say here is that all of these stakeholders work with climate data, but they work with very different data. So some of it is aggregated, some of it is really broken down. And what I think we should be doing is the same thing in the specific process of the construction industry. This is just basically the so maybe it's worth explaining. So this super complicated graph is what we set out as our own graph to understand how the industry works with carbon data when we first started 2050 Materials. And it got like ever more complex because everyone we were talking to was saying, and then I go and look for carbon data. So the point here is, this is the current, like the status quo around carbon data. And I want to make the point that basically too much data means too much complexity, it's too expensive, and basically nothing happens. So I'm not going to run through the use cases because I know we don't have a huge amount of time, but maybe one thing I wanted to point out, because it's also from last year's hackathon. Last year, we did a really interesting project, or one of the challenges that we proposed was we used the API that we offer as a company, and we aggregated into systems and assemblies, and then build a Revit plugin. And my main point with this is that for this hackathon, what we're doing is that we're offering kind of free access to the APIs that we have with a bunch of embodied carbon data. So if anyone is working on a challenge that needs either embodied carbon data or circularity or something that we might have, please come talk to me and we'll give you an API key and you can play around. And there's also like boilerplate code so that you can already, do the first queries and get the data. So even if you would just want to experiment with the data, I think it's a good opportunity. I will be here most of the time, so feel free to also ping me, and it would be cool to build something with the data.
Thank you very much, Fanos. No, I appreciate it a lot that you open your database for the weekend. Mm-hmm. I think it's very interesting for everyone to kind of have a look. And it's also impressive to see how things developed. I remember like talking to you 2 years ago where most of your users were still stuck in the user interface and you built configurators and stuff. And now I think you really brought it to a whole different level. And
yeah, I mean, one of the things that we realized early on is we could build certain tools for specific companies and specific regions, but we realized that there's so much customization that actually happens in the industry that it would be impossible to build tools for everyone. So it's just much easier to give them the data and empower them to use it to build their own tools. So I think it's also just cool to sit in the position of helping people build things, and then the things they build, they really fit their use case.
So your value proposition is basically cleaning data, collecting it, cleaning it.
It's a lot of collection of data that sits in PDFs. We parse a lot of information. We categorize it according to a bunch of standards and systems, and we make it as plug and play as you can have it, basically. So it saves you hours and hours and a small data team that you would need to have to collect probably less data than what we have.
It would be interesting to hear your perspective on digital product passports, but let's talk about this in a minute.
Yeah, for sure.
Hans-Uli came to the stage because he's adding to this. Talking a bit about like what regularities are there and what's coming towards us.
Cool. Yeah, thanks again.
Thank you very much, Fanos. Oh. Einfach hier. Okay, yeah, the stage is yours, Hans-Uli.
Thank you very much. My name is Hans-Uli Schmid. I work for the Swiss Wood Federation. I'm a joiner and wood engineer. I studied in Biel, and I worked several years in the construction products industry, and now since 10 years at Lignum, Swiss Wood Federation, as I said. And there we work on the different basic requirements to abolish the barriers we have, or we had. For example, fire safety. There was a big limitation until 2015. We worked on it, on solutions, and we are now able to construct buildings like any other building in wood. Other topic is sound insulation, and therefore we developed a lot of books, written books, PDFs, etc. And now we started to bring all this information together on one platform, which has now also an API, which can be used by the guys we heard before. And basically, when we started, we found out that actually to talk only about products is not sufficient. We have to provide as an industry solutions in components which have already some properties the architect is looking for in an early planning stage. He can already make first calculations and bring requirements and performance together from early planning stage to the final project. But all those levels are connected together. It's data which has is related and connected together, and therefore we worked on this collection. We have over 900 components freely available online, and we made all the like tests for sound insulation. We have connected it with the KBOB environmental information. We made first calculations there. So we are now very interested to see what you guys doing with all this information. You can see here the KBOB data for one component also calculated. You see the beneficial impacts like the stored carbon in the wood in green. And now there is a regulation coming in Europe. Everybody who is introducing a product, construction product, must provide his information in a machine-readable way called the Digital Product Passport, and it will include the environmental impact values. Therefore, we started to investigate how we can provide such a digital product passport for the wood industry, and we are one of the first industries to provide such a solution where we have a generic description where you then finally can specify it and create a QR code with a permanent link. And then you only put the link in your model, where then your model is actually communicating with the database via API to get the data needed in your specific use case. This is now online. You can try it and can already also scan it. So we are already used this API. Several industry partners use this API to provide information about their specific information. So we have more generic information, and then we can make specific out of it. You have also tools like Greenbeam, which are accessing the data and then make also calculation for early planning stages. This is the law about the DPP. So somehow written, even in the European law, you can read the word BIM. So they do it the right way. They think about not only to provide information, but it must be accessible. And this digital product passport will be introduced latest on 2028, not so much time. And manufacturers have to figure out how they can solve these new requirements. There will be service providers, big company will do it by themselves. But there will be 2028, the possibility to have much more information for the planning. An important topic is data dictionary. So the digital product passport will be based on common data dictionaries to have a common ontology that the computer finally can read all the data. And also there's the problem. Standards are now human readable in different human readable languages. It's not translated into data dictionaries, and that's certainly a topic we have to solve in the European standardization. I work also for Building Smart International, and there we see that the common data dictionary is a very important platform to solve this problem. As a European wood industry, we took all 14 harmonized standards for wood and created a common data dictionary to describe the product in the future in the digital product passport. So this is also available, and I would suggest that you try to access this data and figure out how you can use in the future such digital data dictionaries. Because the data provided will be in this same language. In the same time, we also discovered that LCA data has no dictionary, so we created a dictionary for LCA data and EPD. Another topic we discovered that we have actually high quality data in Switzerland available, but in different Excel files, not very structured. And it would actually be nice to have this data in a database with API. And let's see, let's hope that SCA and KBOB get inspired and will maybe bring those things together and make it a bit easier for us to use this data. You can try to use the data, we'll find out. The computer cannot read it at the moment. Generic data is very important to have. We should not only talk about the specific data, we need in early planning stages reliable national generic information. And that's why I wanted to put it here on the screen. Published soon, a guide for project management with BIM and timber construction. Anne Niefeler was the main author of this document. Will be printed this month, and we are very excited to publish this document soon. That was it from my side. Thank you very much.
Thank you very much. It's 2025, and we wish for a simple API to access data. But just one last comment. What got me thinking here, I mean, now we talk about that we have standardized data here, we have some public data, and it's accessible through an API. But another part of the problem is that all these assemblies that we see here are most likely described differently. Like there is no assembly JSON, which is something that's so simple, and that's something that should be done by the industry. I mean, how do we define an element and how do we describe it? It's bottom up. It's not so difficult. The question is how can we play and make it happen? Probably opensource.construction also needs to think about providing such services because it's not so difficult, but would help a lot. Philip, now it's your turn. Let's cross fingers.
Check. Mikro. Funktioniert?
Mikro funktioniert, the screen auch.
Yes, let's see if we can put a little bit of extra information on top of this. So thanks a lot for the invitation. Philip is the name. Today I want to introduce you to some long forgotten concept which might help. Ontologies and why they could matter. 3 things. First, I want to focus down on the problem, which was tackled sometimes now. Then I will go into a really short introduction about the concept of ontologies and come up with some small basic solution, which might also help here for the hackathon. But let's get into it. Because the problem which we're tackling here and we were talking about is not young, it's pretty old. Whoever doesn't know, take the barcode. It's an old video on YouTube. It's amazing. This guy talks about, it's 30 years old, and they talk about the very same thing. Cooperation, and how do we share information? And then what the guy says is, and then came this amazing invention, which makes everything worse. What is it? The personal computer. Okay, now let's turn it into now. Because if you have nice and structured data, yeah, you can do amazing things. Problem is, most of it inaccessible, siloed, proprietary, you can't do anything. And now we have all these fancy tools. And don't get me wrong, you can do a lot of this, but if it's shitty data, there will nothing come from it. It doesn't matter if it's machine learning, artificial, whatever, general. It even gets worse. Because a lot of stuff which is produced this year, 90% of the data which we own now has been produced the last 2 years. My kids came with this one. If you generate a lot of data, there will be a lot of shitty data. See the problem? Sorry, there are no bones in the trunk. And not in the ear. And it's getting even worse. Because the traditional methods, how we look for information, get spoiled with all this produced information, which is completely misleading. Sorry, a baby peacock doesn't look like a peacock, just in small. This is completely wrong. If you use Google search pictures, you're lost. Okay, what to do? Again, pretty old concept, 2001, so 24 years now. And there was the idea to give ontologies, which don't only talk about the content, but also the context, so the relations in between. Question, everyone knows what the triple is and the RDF? Really short explanation about one of the basic concepts. RDF, again, old, no invention from me. It's working, it's out there, it's stable. And you can do, with the resource description framework, you do triples. Subject, predicate, object. Really small sentences, right? The Beatles are from the type band. It's a W3 standard, so it's highly standardized. It's available for anyone. This can be expanded to any direction. The Beatles are a band, the Beatles have these members, these have been doing these songs. You can display it in any direction, like a map. And I kind of like maps because they give you some direction. One of the representation of this information you may know. Things can go really big and you can't destroy them. And they're really, really, really fast. 1,000 times faster than any other database I know. One of the possible representations is Wikipedia. So what you saw as a graph, the triples form a graph, which can also be displayed as an article. And then you can see and read about the Beatles. If I now want to know the members of the Beatles with the date of birth, I could read it as an article because some people thought, hey, an article is a nice way for this information. But I can also query it. And query it means I send a query to the Wikidata, which is the database behind, and I get the members of the Beatles on the timeline. Now think about construction data. If you have information at hand, we say, this I want as a pipe chart, and this I want as a timeline, and this I want as a BIM model. Might come handy, right? So if this is a data model, there are two things which you need to know. The one is the A box and the T box. The one is a concept, and the other one is a content. And it both comes together. Because part of it is like the A box, which describes there is things like a band outside, there is things which is a construction outside, and the other one has been filled from other software, which says the Beatles have, this is a name from the Beatles. But just to display the context, you have both. You have the content and the relations in between. Now, one of the problems which we face is people use it in different ways. And you have different statements. And sometimes you find, let's say, misleading information. If you look at the internet, you will probably find some say the world is flat. And some say that the immigrants are going to eat our pet. This is a problem of the internet, because the internet follows the AAA principle. Anyone can say anything about anything. And it's you to find out and to deal with this information. You have to figure out if it's like this or what. But the nice thing, it also lets us deal with the complexity which is outside. And construction is complex. Is this door red or is it orange? Depending on who you ask. Is it better if we would build this building in wood? Depending how you calculate. So it's always like multiple versions of the same information out there, and how can we make sense out of it? So if you have this simple thing and describe it in triples, and say, hey, the door is red and the door is green, right? Has color red, has color orange. What does the machine nowadays do with it? We feed it to ChatGPT, ask it what color does it have, and it comes up, sorry, like you probably would too, say, hey, this is inconsistency, I can't answer this question because it's like, yeah, too misleading information. Now we give it context. We say, hey, the one information comes from some algorithm and which was produced by a photo. And the other information comes from a guy, and the guy has an email address, and the email address belongs to the company, and the company is same concept, feed to the machine, and now we ask for the color of the door. And what does it say? Probably the same thing what you would say. Yeah, by chance, this door is red because this is more trustworthy. So if a machine finds this context interesting, means not content is king, context is king. And now we have the ontology which are able to describe this context and the relations in between. And they're standardized. And we can make use of them already because they're out there. Decon is like an amazing collection of different things. There's WGS 84, GIS. There's IFC-all, how to use IFC in some real data format. There's things about organizations. There are things about time. Everything is out there. I bet 90% of the data you deal every day is covered already. Someone describes the thing already. You don't need to invent it again and again. For example, amazing standard, the ICDD, information container. That's an ISO standard, and this is the way how you can dig into it. It's about documents and how documents are related into containers, and then there's something like an author, and the author produced this one, and you fetch it right over there from iso.org and play around and make use of it, and take the things you need, leave the rest away. And there are some more standards out there, like the real estate core, asset owners, brick schema and project haystack, HVAC, the bot, the really basic building ontology terminology, which describes the building really easily, or the ISO standard, which is the information container for document delivery. And one of the things, if you have these concepts, how do we produce the data then? And let me show you one really interesting thing, and I've put it on the Discord platform to play around, because this is out there, and it uses an LLM to produce structured data from text. And this is amazing, because what this thing does, and I can make it run here on notebook, you download a notebook, you install it, you feed it text, and you get structured data from it. Imagine having like a description from a building, all the documents from collected, and turn it into some structured data model. Test it out, it generates a brick schema independent from the files. Two explanations. The one thing is here, gets a notebook, download, use your API key for whatever, for ChatGPT. Then you go and fetch the code, and then you can make it run. Runs on a laptop, takes about some minutes, but it's working really well. The other thing which I was also feeding into the Discord channel, if you want to look into an ontology, what is it, and play around. Use a Visual Studio, and there are two files up there which you can load, and you can start playing around and dig into and start playing around. Thanks a lot.
Thanks, Philip. Very interesting. What always helped me to understand also the relevance of schemas, basically schema.org. Like whenever you want your website to be found by crawlers, you would like ideally describe it following the schemas that are described on schema.org. So Google and other crawlers find it and index it and make it more visible. And I think at some point we just have to get to this point as an industry as well, that we say, if you want the information to be found, follow this schema and describe it in a way that LLMs and other like machines can actually deal with it.
Mm-hmm. And then schema.org is like from the GAFAs, so Google, Facebook, and co guys, right? They were like, it doesn't work together. Let's do this open source. Let's do a schema so we can know what you're talking about. Amazing. I mean, these guys normally don't like each other very much.
But they know it helps if they do it and everyone can align with it. And today what we see in the construction industry is that every owner procures data in its own format and says, this is the way we want to have the data delivered by you guys. And that's why I think, at least in my perspective, that many organizations really struggle with this, that there's no guideline that they can follow, but they always have to adapt in every project again to new requirements, and which makes it obviously much harder to automate stuff.
Yeah, but once you have it in real data, it's really easy also to transfer, right? I call it this way, Fliesen. How do you call it? Plättli.
Yeah.
Okay, let's do Fliesen, similar as Plättli.
Yeah.
So he keeps calling it Plättli. I could call it in Fliesen. Doesn't matter. We can cooperate.
We are getting there, I hope. So please, Michael and Hans-Uli, and Fanos, if you would like to come up to stage again. Ah ja, mach mal das. Steuerung muss gesamt. I would like to pick up where we left Fanos when he finished his presentation. Like, what's your take on this digital product passport? Because to some extent, I feel like the industry is leaning back and say, okay, now there's some regulations coming. Until we know what's happening there, we don't do anything because we just waste energy. So, but it sounds like a bit too complicated and a bit too ambitious what they really plan to do with the DPP, that it's realistic to be implemented in like a realistic time frame. So what do you guys think? Probably Hans-Uli a bit about how complicated are DPPs really, and how feasible is it for like also small scale manufacturers to comply with these standards?
Yeah, as I showed, you can create like a similar DPP, but to have then really the information connected with the common dictionary. And yeah, there are still many uncertainties, but the CEN-TC 422 is working group 15 is now working on a specific solution, how to make it, right? Because now the law is just describing what needs to be the outcome, but how it's really made is not clear.
Anders, what's your take on the impact of DPP?
I come from a little bit of a different perspective. I think like the work that we have been doing is, even though we never intended to do that in the beginning, is essentially putting together digital product passports, maybe not in their final format that the regulator will be asking for, but it's actually quite nice to see that regulators are indicating that there needs to be a certain format, there needs to be in JSON, there needs to be a platform, like there's all of this information, which to me is positive because it actually aligns with what the industry has needed up to now, at least some of the more concrete recommendations. And my perspective is, yes, it might take time to get there. And yes, some organizations and maybe the manufacturers will lean back and say, okay, until the regulation is there, we're not going to do anything. But the design industry already needs a lot of the data that goes into the passport. So companies like us will keep collecting it, will keep building passports. And then when the regulation is more concrete, we'll align them to whatever they decide. So I think it's positive. It's a positive sign. It gives us an indication of what's coming, and it also confirms in a way that what the industry has been asking for is actually taking into account when building the regulations, which is not always the case.
Thanks a lot. Michael, one question to you that came to my mind when you showed the assemblies, and then it's not only about environmental data, you also have like fire safety, you have other hazards and other like ingredients. How easy is it for you to collect this data? Because now we have Fanos with 2050 and the lignum database, but it's always only covering a part of what you need, right?
I think it's a manual process that it's basically looking at all projects, getting in touch with engineers, stuff like that. So I think it's kind of to build up some information level, because it's not only the planning data that is interesting. It's really the finished projects we're hunting for, basically, that we understand what came into existence as a final step. That's one thing, but I think it's something that's, let's say, to touch upon what Fano said, is, I mean, in the future, these data structures most likely will change, and there will be, let's say, adjustments needed. But I think once we have kind of a base layer, it needs these kind of, you have these transformers, I think, to deliver different kind of information sets, let's say, different formats, and that's exactly what will end up. Basically, will change the data set in the future. But I think it's have some modularity, and we don't want to, let's say, wait for something to be finished. We need a product or a service and API now, and we don't want to waste too much time on this, because there's other things to do that take more time, basically.
Thanks. Probably one last question before I open the mic to everyone. Philip, you've been working now with many organizations over the last couple of years, and the things you're talking about, like semantic description of data and ontologies and all of this, require some sort of data governance, right? Like, data is coming from somewhere, someone has to be responsible for the quality of it, it has to be published. What's your take on how many organizations in the construction industry are ready to really talk about data governance?
I have this one, it's still on, right? So, few, 10%, maybe. I mean, huge organizations like we have here, which have capable teams, they can handle this stuff, and they have regulations. Small ones are mostly of the time lost. And they're also lost because trying to make the way they work fit into some rigid tree structure, which is given from outside, doesn't meet their needs, right? And the world is just too complex to feed it into a tree. The world is too complex for lines and columns. It's diverse and changing all the time. So probably we could fill everything into these structures, even if it's like for the passport or for the IFC schema, what has been built, but we will never be able to fill in what will be built. The future will change, and it will someone will come up with some stupid idea, no one thought of, and then it doesn't work. So we need like more flexibility. Have the IFC wall with an opening and some door, and then you want to put in the ceiling. It doesn't work. Didn't think about that again. So you need to wait for the people to. Why couldn't I just edit? Right? And this is as long as this doesn't work, probably there will be no governance.
And what's needed that it works? Like, what would you recommend to owners of small scale, like SMEs?
Open tools everyone can work on. And it will be only soft. Not a small company cannot solve it themselves. This is about community and sharing ideas and pinning out and say, look, this is out there already. You don't need to invent the wheel again. Take it, use it, make it better.
It's interesting talking about schema.org, that like the large big tech companies came together and said, if we want to make the web content accessible, we need to describe it. So let's come up with a schema that everyone can work with. The question is, who in the construction industry would take over this role? Probably at some point it's big tech, because they have an interest in digital data, and then they come and say, hey, but it's an open question. So probably let's talk about this.
Hey, Pablo from Builders AI. We've talked about this before at the IFC Implementers Forum, the linked data, schema.org, making things crawlable. I'd love to hear your guys' thoughts on what data sets to prioritize for making accessible. Imagine it's part of IFC 5 that linked data is much better supported. We're all starting to move data towards GitHub. What do we focus on? Is it the parts of the buildings? Is it the buildings as a whole built project? Parts suppliers, marketplaces? What's the priority?
Who wants to answer?
So the priority, which data has to be delivered, is already defined today in the construction product regulation or in the different construction product standards. where the essential characteristics are defined, which are really legally binding for the security of the building. So those data will be required also in the digital world. In addition, now coming the LCA data, EPD data, which is not yet sure if it's the whole set, but certainly GVP is there and primary energy, I can imagine. So this is the legal required data, but there will be, of course, from the planners, other data naturally asked, and so there will start a competition of sustainability. So this information will be part of the competition and of the differentiation, and so it makes actually sense to bring this data in as a required data. Or if someone...
Yeah, I don't know if it's going to solve the real question, because when you delivered it in IFC 5 point, 6 point, 7 point, whatever, right? It's just getting bigger, 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 200,000 entities and growing. And still you need to decide, is this thing now heating or cooling, or is it electric? Well, in winter it's heating, in summer it's cooling, and it has an electric fan, so it's electric. Okay, which of the boxes do I put it in? Shit. Can't exist in three boxes at the same time. Why not? Tree structure, wrong word. And then even if you describe everything with metadata on it, and you have like, I was lately looking into some BIM model that was like minimum diameter of a valve, 90, maximum 90, actual data 90. Nice. So we are really good in documenting what it is. We completely forget why. Whereas a calculation that led to the assumption to choose 90. And what standard at that time was applicable to do this calculation this way to come up with 90? And what standard is now, if I recalculate, lost. If you don't cover the connections, you're fucked.
I think everything that is incomplete doesn't help on delivering a project, basically. I mean, it's coming with, when you look at technology, like startups, they come with a minimal viable product. It's hard to test and use that, basically. So even on the data thing, I mean, you need a project. That's what you're contracted for. And if it's incomplete, it's always hard to jump, basically, on something that is not complete. So that's a big problem. You have to make money with projects.
Another question from the audience?
So it's really interesting to see the pictures that you put up from Herzog de Meuron about the different kind of contracts around the world and the different kind of the plug sockets of everyone's got different requirements in different places. I was interested to hear the colleague talking about priorities and prioritization, and interested to think about like the lignum, the databases that we have there. There's also the Dataholz one, which is also something similar. It's also going in your direction of having a whole series of different categories and priorities of different things there. That's quite interesting, but do we need to solve it for every project every time? I mean, I'm currently working with Judith at Gropius in the product evolution. I was previously employed at Calatrava doing all sorts of wacky stuff. So both kind of the Herzog de Meuron bracket, I'm also involved in that. Why can't we just solve it for the 90% of the normal projects, the square boxes that Anna and Rangley build and Gropius will build, and then build out from there? So solve it for the 90% and leave the 10% for the future.
I mean, that's a good question. Who represents the 90%? So is it you or us? And I think none of us currently. So I think the fragmentation is a huge problem, basically. I think I touched upon in the first session. Again, kind of here, it is something people are overwhelmed. It's hard to onboard. The whole digitalization in that sense is the topic. And I think it needs basically both sides. Basically, I think that's well, let's say the 10% and the 90% at the same time, kind of to push back and forth. It's tricky. Yeah? No answer for this.
But the question is like, who would regulate it? That like, is it with schema.org? It's big tech that just came together. Who would say that's the way we do it? You know, it's like a no. Okay, now you're done. Yeah, it's I let you. I also.
But I think it's. I mean, this is something. This idea of the, let's say, the media and entertainment industry and the big players like Disney and others. That's kind of, it's the same thing. They define together a universal scene description as the format, basically, and the others have to follow. And basically, it replaces proprietary formats, and all software solutions are apps on top of that. I mean, maybe it's most likely there are problems there too, but it's the big market that defines it, and there's no big market here. Big market players.
But obviously, change is happening. We're moving away from file-based processes to database processes, and there's web technology, and there's API, and there's all of this really requires more standards than we had like only 5 years ago. Although obviously IFC and everything is around much longer, but I mean, the pain is only growing now, and I think this pain will hopefully at some point either help like you guys to sit together with Erne and Renkli and say, hey, that's the schema of how modularized construction has to be described, and that's what we align with each other. So you just make up your own group because it's not the same like all the other buildings, or these groups will form, I guess.
Yeah, but just a bunch of IFC files on a server in the basement is not real data, right? It's, go ask, hey, what is the element which caused most of the trouble? Probably won't get no answer.
But that's where people get to now. They have all these files on a server and they can't access it, and they say, okay, like how much money did we now invest into BIM, and what's the result out of it? And I guess there are lots of ideas around that we can build upon, hopefully also on the weekend with the hackathon. And looking at the watch, I would say we conclude this session for now, have another short break to get some fresh air, and then we kick off the hackathon with the presentation of the challenges, and move to the apéro riche afterwards. So thanks everyone. Thanks everyone for coming. So it's basically another half an hour break, and then we meet again here. Philipp, kannst du das vorletzte Slide mal zeigen und dann Rezept drauf? Welche Musik?
How does it work here? Do we present some?
I would like if you didn't change your slides, right?
I create a new one.
I
Yeah.
just have the ones that you sent me, like.
Du machst noch einen Hinweis auf die Discord Resources.
Ja. Das machen wir jetzt dann gleich. Ist es noch online?
Yeah, I don't know.
Is it in the challenge? Is it in the list presentation?
So, like, you know, you said like 3 slides.
Yeah,
So
okay.
I made like 3 slides.
Yeah, fair enough. I mean, you can, it's a